All right, so today we're going to be looking at solving equations using exponents. Now, you may recall that exponents are raising things to powers and also taking roots. So we're going to be looking at both of those. Now, because of the nature of your course, we're only going to look at squares and cubes because you will not be looking at anything much further than that. And so in regards to roots, we'll only be looking at square roots and cube roots for the exact same reason. But the same principles will apply for quartics, quintics, sextants, blah, blah, blah. So to any power, honestly. Now, let's see, how do you solve equations using exponents? Well, let's start off with this one here. X squared equals 9. Well, what number squared equals 9? That's what you would probably ask whenever you first learn square roots, right? That's because in order to solve for this unknown value, or in order to undo a square, you take the square root. Now, I'm going to show you two ways to help you understand this. If you understand the first way, don't even listen to the rest of that part. You can watch it, maybe mute me, then come back. Okay? Um, but if you don't kind of all get this first way, keep listening to the second one and see if that helps you understand things a little better. It all has to do with fractional exponents. So I'm going to show you the first way first. So to undo a square, we understand that we need to do a square root. So if I see this is something squared equals 9, to undo that, I would do the square root of both sides of my equation. Okay? Now in doing so, we know then that the square root of x squared would just make this x. How do you know that? Well, x times x equals x squared. And if I take the square root, that means I'm trying to find what number do I multiply twice to get what number do I multiply twice to get what's inside of here? Well, if I have x times x to get that, I would have to multiply x times itself. Oh, so in other words, they undo each other. So this is the first method in which we use in order to understand what's going on. Let's do the same thing here for the 9. What's square root of 9? Well, what number times itself gives you 9? Oh yeah, that's 3. Or -3. Which one is it? Well, it's both. Could be either or. Both are correct, right? If I take -3 and multiply it times -3, I get 9. If I take 3 and I multiply it times 3, I get 9. Well, which one do you use? You would traditionally in mathematics courses, you would write both answers because both answers are correct. Having one without the other would be you missing a piece of it, right? Of the answer. But when you're doing things technically in the more real sense or a real situation, you would generally only use the positive version of it. Generally. There are instances where you want to have the negative answer so that you can evaluate the equation from there and maybe you get a positive result with that negative in there that is actually possible to use. So you need to understand that both of these occur. But generally, when you're doing problems involving this, you're only going to have the positive version of the answer because that's going to be the part that matters because you're dealing with positive lengths of things. You're going to have negative lengths. That wouldn't make sense in this world, right? Okay, so real-time teaching. So that is the first method I'm going to show you. The second has to do with thinking of this as fractional exponents. And this is the thing that made things click for me a lot more. It helped things click for what a fractional exponent was as well. So let's take a look at that. And it all actually has to do with what I just wrote down there. So if you were to think of it this way, x squared equals 9. Well, I want this just to become x, right? What would you have to multiply 2 by, or what would you have to do to 2 in order for this just to become x? Wait, it's not 2 times x. No, it's not 2 times x. It's just x to the second power. I promise. But what would you do to that 2 just so this would just be an x? In other words, how would you make that a 1? I would divide by 2? Yeah. But not down here, but just to that exponent, okay? So let's do that. remember, our equation needs to be balanced. It has to be balanced because it says it's equal. If we do something to one side, we got to do it to the other. So I'm going to take the 9, and the exponent on the 9 would be a 1 to start off, right? Because it's not being raised to anything. It's just going to have to stay 1. So I'm going to divide that by 2 as well. Okay. All right, so 2 divided by 2 is what? It's 1. Good. So we got x to the first power, or just x, and 9 to the 1/2. What does that mean? Well, when you've seen fractional exponents before, 9 to the 1/2 actually means square root of 9. In other words, this is asking what number times itself gives you 9. But we know that that is plus or minus 3. In other words, positive or negative 3. So the same thing as written up here. Okay? So both methods are correct, and they both are doing actually honestly the same thing. It's just written differently. How do you undo a square? You take the square root. How do you undo something raised to the second power? You can divide that power by 2. Whatever you do on one side of the equals, you do on the other side of the equals to keep it balanced. And then you simplify. And both times we still get plus or minus 3, or negative, positive 3. Okay, cool. Let's look at the cube, shall we? Okay, so let's look at the cube. So if we take that same principle with squares and square roots, and apply it to cube roots and any other roots, this will be still simple. X to the third power, x cubed equals 64. Well, how do you undo a cube? Well, to undo a square, you take the square root. To undo a cube, you'll take the cube root. So you take the cube root of x to the third. And because it's an equal sign and these need to stay balanced, whatever I do to one side, I need to do to the other. Okay? All right. You can also think of it as like, if these are equal, it's substitution, right? So if I want to take the cube root of x to the third, then I have to take the cube root of 64 anyway, because I can sub 64 in for x to the third. Okay, so if these undo each other, we're left with x. And what's the cube root of 64? Well, what number times itself 3 times gives you 64? Well, I guess that would be 4. You are right, cyberspace. Good job. Okay, so if I showed you that in the other way, x to the third equals 64. What would you do to the 3 in order to make it a 1? You would divide by 3. Since there was no exponent here, there would be a 1, so it would be 1/3. But we know that that would just give us x, and then the cube root of 64. Or what number times itself 3 times gives you 64? So we get 4. All right, awesome. If you're looking for more information on how did I get the fractional exponents and how those work, you can look at one of my other videos on fractional exponents. Well, let's now look at doing this when we start off with having a root of x, like a square root of x or a cube root of x equal to a constant term.